omega t dt. This is the formula equation number 1. Signal into e power minus j omega t dt. So what I will do, I will substitute the signal. Given signal is e power minus at u of t. This is the signal. Signal into e power minus j omega t dt is the formula. Because u of t is present, which is right-handed signal, limits can be changed as 0 to infinite. U of t means it is step signal. It exists only for positive time. Negative time signal is 0. Negative time signal is 0. So only positive time u of t exists. So integration limits I am changing as 0 to infinite. Now what I will do, u of t value is 1. I will put in the place of u of t value 1. So e power minus at into 1 into e power minus j omega t dt. And if I combine the exponentials, what will happen? Powers can be added. If I combine powers can be added. This is 0 to infinite integration limits. Okay. Now what I am trying to do, one single exponential. How I am doing this? A power into a power n is nothing but a power m plus n. A power n into a power n is nothing but a power n plus n. Harish, kindly mute your audio. Harish. Now coming to, this is the formula what I am using. And now LHS, it is x of j omega. LHS, it is x of j omega. So RHS, integration of exponential is, so we already know that integration of e power ax is nothing but e power ax divided by a. We are doing integration with respect to x. So dx will be present here. Okay. So same thing I will apply for the previous step. Minus of a plus j omega into t divided by minus of a plus j omega. And I have to substitute the limits. 0 to infinite. Okay. So this is the basic formula we know. I am using it. And now in the next step, x of j omega is nothing but minus 1 by a plus j omega is constant. In the place of t only, I have to put the limits. So e power minus, okay, a plus j omega into infinite. E power infinite into anything is infinite. Minus substitution of lower limit. In the place of t, I am putting the limits. Now this will become 1 by a plus j omega. And this is 1 by e power infinite minus 1. So e value is 2.71. 2.71 whole power infinite will become infinite only. So 1 by infinity is 0. So now 1 by a plus j omega. Here 1 by infinity is 0 minus 1. So finally I am getting x of j omega is nothing but 1 divided by a plus j omega. This is Fourier transform. I completed calculating Fourier transform. Okay. Now I will go to the spectrum. Sketch the spectrum. So I had x of j omega is nothing but 1 by a plus j omega. I am calculating spectrum means modulus of x of j omega and then phase angle of x of j omega I have to calculate. Okay. So if a plus jb is there, modulus is nothing but square root of a square plus b square. So I will do it for numerator and denominator separately. Numerator 1 means it is 1 plus j0. Imaginary part is 0. So modulus is nothing but square root of 1 square plus 0 square. And it is 1 only. So numerator magnitude is 1 and denominator magnitude is a square plus omega square. This is magnitude completed. Now I am going to phase angle. If I have a plus j omega, if I calculate the phase angle, this is plus tan inverse imaginary part by real part. If I have denominator factor 1 plus a j omega, 1 by a plus j omega denominator factor, then the phase angle calculation is minus tan inverse imaginary part by real part. Okay, all these are basics. All these are basics. I am doing that for our problem. Okay, so magnitude completed. Modulus means magnitude. Modulus means magnitude for numerator, magnitude completed for denominator also, magnitude completed. And this is our equation 1 Fourier transform. Now I have to calculate the phase angle for this Fourier transform. Angle of, phase angle of, okay. So if I have 1 by a plus j omega, phase angle is minus tan inverse imaginary part by real part. Imaginary part by real part. This is phase angle. This is magnitude and this is phase angle. Okay, if you want, you can put it in bracket, or angle. You can represent the angle also. Okay, this is magnitude and phase angle. So spectrum means frequency domain diagram. Spectrum means frequency domain diagram. Now I will make a table, omega value. What is the magnitude? If I put that omega value in equation, let this be equation 1a. In equation 1a, I have to substitute omega value. What is the magnitude becoming? And when I substitute omega value, what happens to the phase angle? I am preparing a tabular column. Using equation 1a. I will just calculate the magnitude and phase angle. Okay, so I will put 0 and then plus 1, 2, 5, 10, infinite. Negative side also minus 1, minus 2, minus 5, minus 10, minus infinite. For all this omega values, what happens to the magnitude and phase angle? Because I have calculated, I will directly copy it. Okay, otherwise you have to put it in equation 1a and simplify. Put omega value 0. Just I will calculate for this. In equation 1a, if you put omega value 0, 1 divided by square root of a square plus 0. 1 divided by a. Magnitude is 1 divided by a. Okay, and then let me assume a value as 1. Just I will put a value as some, just it is my assumption. If I assume some value for a, anything you can assume, just based on that our calculation will be. I will assume a value equal to 2. Okay, so 1 by 2 means 0.5. 1 by 2 means 0.5. If I put omega value 0 in the phase angle, in equation 1a, in the phase angle, this portion is phase angle. I have to put a value as 2. Omega value as 0. Minus tan inverse 0 will become 0. Okay. Now for calculation of this, I have to put omega value 1. And now what happens to the calculation? 1 divided by square root of, okay, so a value is 2. 2 square is 4. 4 plus omega value I am putting 1 square. 4 plus 1 is 5. 1 divided by square root 5. So here I am getting magnitude as 0.447, and phase angle similarly if I substitute I am getting something like this, and for 2 I am getting 0.35, 0.185, 0.09, and for infinite, if you put infinite, omega value infinite, 1 divided by infinite is 0, irrespective of a value. Okay, infinite is very, very high compared to a value, so denominator will be completely infinite. 1 divided by infinite is 0. Okay, so like this I am putting all the values, a value maintaining as 2, and for every row omega value is different. If I put this, I am getting phase angle like this. And the same values will come because here omega value is polarity different. All the plus values I have calculated. For minus values it is just opposite. Okay, but for magnitude you are doing square, so it will be 447 only. Phase angle will be 26.5, and here magnitude is 0.35, 0.185, 0.09, and 0. Phase angle will be positive, opposite polarity plus 45, plus 68, plus 78.7, plus 90 degrees, plus 90 degrees. Okay. So these are the values from the tabular column. These are the values from the tabular column. Now spectrum means frequency domain representation. What I told you, frequency domain diagram is nothing but spectrum. Frequency domain diagram is nothing but spectrum. Just I will draw the spectrum, by that this problem will be completed. Spectrum means diagram in frequency domain. Diagram in frequency domain. So what I will do, I have a tabular column here. I will take first column and second column values. Second column is mod x of omega. Second column is mod x of j omega. And first column is omega. Okay, and initially it is 0, then 0.09. I will take x-axis plus 1, 2, 5, 10, infinite. 0 is there. Minus 1, minus 2, minus 5, minus 10, minus infinite. Okay. At minus 10, it is 0.09. Then at minus 5, it is 0.185. And then minus 2 means 0.3. Then 0.4. At origin, it is 0.5. Again 0.4, 0.3, 0.18, and 0.09. And 0 at infinity, it is very close to 0. So this is the diagram. After marking the points, join them. This is called magnitude spectrum. You are drawing the diagram for magnitude. You are joining all the points. This is called magnitude spectrum. You are drawing the diagram between first column and second column. First column on x-axis, second column values, you mark it on y-axis. Okay, you mark on y-axis, diagram between first two columns, it is magnitude spectrum. Now coming to phase angle spectrum, x-axis is omega, first column, third column. I am going to draw diagram between first column and third column. Third column is angle of j omega. First column we are having 0, 1, 2, 5, 10, infinite, minus 1, minus 2, minus 3, minus 4, minus 5. After minus 2, we are having minus 5, minus 10, and minus infinite, something like that. And at 0, phase angle is 0. At 0, phase angle is 0. So y-axis, what I will do, let this be 25, this be 50 plus 75 plus 90 degrees. Negative side also I will take minus 25, minus 50, and then minus 75 and minus 90. Okay. For 10, minus 10. For minus 10, angle is plus 78. So minus 10, angle is positive side 78. And minus 5, angle is 68, positive side. Minus 5, 68 means y-axis value somewhere 68 here. And minus 2, it is plus 45. This is minus 2, 45 means somewhere here. Okay. At minus 1, it is plus 26.5. Minus 1, it is 26. And 0, it is 0. Next, coming to positive, plus 1, it is minus 26. Plus 1, it is going negative, minus 26. At plus 2, it is minus 45. Plus 2, it is minus 45. And plus 5, it is minus 68. Plus 5, it is minus 68. And plus 10, it is minus 78. Minus 78. Then it is going to minus 90 at infinite, plus 90 at infinite. Now join all these points with free hand. Join all these points with free hand. This is called phase spectrum. Okay. Now the first diagram is between omega and magnitude. First diagram is between omega and magnitude. It is called magnitude spectrum. And second one, it is diagram between omega and phase angle. This is called phase spectrum, magnitude spectrum, phase spectrum. And together, these two together called as frequency response. Spectrum means frequency.